Hello everyone, in this lecture we are going to complete the introduction of chapter complex number and quadratic equation of class 11th. So we are starting with the topic power of iota. As we know, iota square is equals to -1. We have studied it in the beginning of the chapter. So the iota cube will be iota square multiplied by iota minus 1 into iota, which becomes iota. Iota 4 is iota square which is minus 1 square and becomes 1. Iota 5 can be written as iota cube into iota square, iota minus 1 which becomes minus iota. Iota 6 is iota cube square, 3 2s are 6. Iota cube is iota minus iota. Square minus square plus iota square is minus 1. Similarly, iota 8, iota 4 raised to power 2, 1 raised to power 2 becomes 1. So we have iota raised to power minus 1 can be written 1 upon iota. If I multiply it and divide it, it becomes iota upon iota square, which becomes iota square is minus 1 minus iota. Similarly, iota raised to power minus 2, iota square upon iota square is minus 1, iota 4 which is 1 and it becomes minus 1. So in general, we can say, if we take the general power k, we can say whenever we get iota raised to power 4k, it becomes 1. Means अगर iota की power 4 का कोई भी multiple है, you will get the answer 1. If iota 4k plus 1, it becomes iota 4k plus 2, it becomes minus 1. Iota 4k plus 3, it becomes minus iota. Now we are going to do the square roots of negative real numbers. As we know, iota square is minus 1, and if we do the minus iota square, it becomes also minus 1. So what we get that iota is also the root of minus 1 and minus iota is also the root of minus 1. So there are two square roots of minus 1, which is iota and minus iota. Similarly, if we do root 3 iota square, we get 3 iota square means minus 3. And if we do square of minus root 3 iota, we get 3 iota square minus 3. It means minus 3 is also having two square roots, root 3 iota and minus root 3 iota. Again, the symbol root minus 3 is represented as root minus 1 multiply 3. Root minus 1 is iota, it is root 3, so it is root 3 iota. Root minus 3 is to be represented as root 3 iota. For any number, it is written as like this. We know that root a multiply root b becomes root ab. but for all a and b should be positive real numbers, right? Like root 3, root 4 becomes root 12. But if we take both negative numbers, it becomes 1, it becomes positive, which is not true. Root minus 1 becomes 1, which is contradictory to this, as root minus 1 is iota, it should be iota square, which becomes minus 1. So it should be equals to minus 1. But if we apply this rule, it becomes 1, which is contradictory to this. So for only positive real numbers, this is true. If both numbers are positive. If they are negative, this is not true. The identities for the real numbers are similar for the complex numbers. As if we have two complex numbers, then z1 plus z2 whole square will be same as it is followed by the real numbers, that is z1 square plus z2 square plus 2z1 z2. z1 minus z2 whole square will be z1 square plus z2 square minus 2z1 z2. z1 plus z2 whole cube will be z1 cube, z2 cube, 3z1 z2 square plus 3z1 square z2. And for the negative, it will be z1 cube minus z2 cube plus 3z1 z2 square minus 3z1 square z2. z1 square minus z2 square will be equals to z1 plus z2, z1 minus z2. These are for all complex numbers. Modulus and conjugate of a complex number. If we have a complex number z equals to a plus iota b, then the modulus of this complex number is to be denoted by mod z and will be a positive number. Root a square plus b square, a real part square plus imaginary square. And the conjugate of this complex number will be z bar and will be a minus iota b. Means you have to change the sign of iota. If it is plus, it becomes minus. If it is minus, it becomes plus. Right? Now, we know that z inverse is to be written as 1 upon z, means 1 upon a plus iota b. If we multiply a minus iota b up and down, we get a minus iota b, a square minus b square, a minus iota b, minus iota square minus 1, minus minus plus. So 1 upon z, a minus iota b is the conjugate, and a square plus b square is the, if we remove the root, it becomes modulus z square. We get a result which is modulus z square will be z bar. The important result, which is modulus z of square, will be z Z bar. Complex number multiply by its conjugate. Further, more results can be derived for the complex numbers, as we have two complex numbers Z1 and Z2. More results can be derived, like modulus of Z1 multiply Z2 is equals to modulus of Z1 and modulus of Z2. Similarly, Z1 upon Z2 equals to, but the condition is Z2 should not be equals to 0. Z1 Z2 bar, Z1 bar multiply Z2 bar, Z1 plus minus Z2 bar conjugate is Z1 conjugate plus minus Z2 conjugate. Z1 upon Z2 whole conjugate will be equals to Z1 conjugate upon Z2 conjugate. Similarly, Z2 should not be equals to 0. These are more results which can be derived.